Dark matter, the invisible substance that makes up 85% of everything that has mass in this universe, and that modern science still cannot identify. Hasn't gotten around to identifying yet. Cannot. Right now, as you're watching this, that substance is passing through the screen in front of you, through the walls of the room you're sitting in, through your own body, completely undetected, leaving no mark, no resistance, no trace. And nobody on Earth can tell you what it is. Here's the part that should really unsettle you. Everything you have ever seen with a telescope, every star, every planet, every glowing nebula, every one of the hundreds of billions of galaxies scattered across the observable universe, adds up to about 5% of the total mass and energy that actually exists. 5%. The stars in the night sky, the ground under your feet, your own body, the entire visible cosmos that humanity has spent thousands of years studying, mapping, and photographing, is a thin coat of paint on top of something vastly larger that we simply cannot see. We gave that hidden majority a name, dark matter. But a name is not an explanation. It's a placeholder for one of the biggest blank spots in modern science. So let's actually go looking for it. Not in some abstract, philosophical way. Let's follow the exact trail of evidence that forced physicists, kicking and screaming, to accept that something invisible has to exist. Because nobody wanted this conclusion. Scientists don't enjoy admitting that 85% of the universe is a mystery. They were pushed into that admission by an equation that simply refused to balance. Here's a promise before we get into it. Everything in this video is built on real, published, peer-reviewed evidence. The same kind of evidence that put rovers on Mars and confirmed gravitational waves. Nothing here is speculation dressed up as fact. What makes dark matter so gripping isn't that it's a fringe theory. It's that it's the mainstream, heavily tested conclusion of modern cosmology, and it still leaves us with a universe that is, at its core, mostly unidentified. The story starts with something you can actually picture, a spinning galaxy. Take our own galaxy, the Milky Way, or any of the hundreds of billions like it scattered across space, vast, flattened disks of stars, gas, and dust, all rotating slowly around a common center, the same way water swirls around a drain, just on a scale that makes vast feel like an understatement. Basic physics tells you exactly how something like that should behave. Near the crowded, mass-heavy center of a galaxy, stars should whip around at high speed, held in place by strong gravity from all that concentrated material nearby. Out at the sparse, mostly empty edges, where there's much less visible mass to hold anything in place, stars should slow down. That's not a guess. That's the same orbital mechanics that governs the planets in our own solar system. Mercury, close to the Sun's overwhelming gravity, screams around its orbit in just 88 days, while distant Neptune, far from that gravitational pull, takes a leisurely 165 years to complete a single lap. Closer and faster near the mass, farther and slower away from it. Simple. Reliable. It's worked for every solar system model ever built. Now point that same physics at a galaxy, and it breaks. In the 1970s, an astronomer named Vera Rubin carefully measured the rotation speeds of stars at different distances from the centers of spiral galaxies, expecting to confirm exactly what the equations predicted, a steady drop-off in speed as you move outward, matching the drop-off in visible matter. Instead, she found something that shouldn't have been possible. The stars at the outer edges of these galaxies, way out past most of the visible stars and glowing gas, were moving just as fast, in many cases, as the stars much closer to the center. The rotation curve was flat. It stayed flat, far out into regions where the maps of visible matter said there was almost nothing left to hold anything in place. Think about what that actually means physically. A star orbiting that far out, moving that fast, based on the gravity supplied by only the visible matter in the galaxy, should be flung outward, torn away from the galaxy entirely, the same way a rock on a string flies off if you swing it too fast for the string to hold. According to the visible mass alone, spiral galaxies across the universe should be actively, continuously flying apart, stars scattering into intergalactic space in every direction. They are not. They have held their shape, stable and intact, for billions of years. There is a direct, glaring contradiction between what the math says should happen and what every telescope on Earth had exactly two options, and both of them were radical. Option 1. Our understanding of gravity itself, built on Newton and refined by Einstein, tested across a century of experiments and successfully used to land spacecraft on other planets, is somehow fundamentally wrong at galactic scales. Option 2. There is a massive amount of additional matter in and around every galaxy that we simply cannot see, matter that contributes gravity but emits no light, providing the extra gravitational muscle needed to keep those fast-moving outer stars locked in orbit instead of flying off into the void. The overwhelming majority of evidence gathered since Rubin's original measurements points toward option 2. Somewhere out there, wrapped around every single galaxy like an invisible skeleton, is enough extra mass to change the entire outcome of the story, and we cannot see a single particle of it. If that were the only piece of evidence, you might reasonably stay skeptical. One anomaly, one measurement, one clever workaround. But it isn't the only piece of evidence. It's just the first domino. And once you start pulling on this thread, it runs through nearly every corner of modern astrophysics, showing up again and again in places that have nothing obviously to do with spinning galaxies. Let's talk about what this invisible material actually is, or rather, what it definitely is not, because ruling things out is how physicists have cornered this mystery. Start with the obvious guess. Maybe dark matter is just ordinary matter that happens to be dark. Cold planets that never ignited into stars, dim burnt-out stellar corpses, rogue asteroids, and dust clouds drifting unlit through interstellar space, black holes that swallow every photon that gets near them. Surely the universe is full of ordinary stuff we simply failed to spot with a telescope. This was actually the leading hypothesis for years, and it has a real name: massive compact halo objects, or MACHOs for short. Astronomers went looking for them using a clever trick, watching for the way a dark, massive object passing in front of a distant star would briefly bend and brighten that star's light through gravity, like a lens flashing across the sky. They found some. Not nearly enough. The numbers don't come close to covering the missing mass. Whatever's out there, it is not simply made of unlit versions of the ordinary matter we already know. That leaves something far stranger. Dark matter appears to be built from a type of particle that doesn't exist anywhere in the standard model of particle physics, the enormously successful framework that already accounts for every electron, proton, quark, and photon ever detected in a laboratory. Whatever dark matter is made of, it does not interact with light in any way. It doesn't absorb photons. It doesn't emit them. It doesn't reflect them, scatter them, or block them. You could stand in a beam of pure dark matter and it would pass directly through your body as if you weren't there at all, and you'd never see so much as a shimmer because there's no electromagnetic interaction happening whatsoever. That single missing property is what makes it dark in the first place. Not black, not merely dim, but genuinely, totally transparent to every form of light in the electromagnetic spectrum, from radio waves to gamma rays. It gets stranger still. Dark matter doesn't appear to be made of protons or neutrons either, meaning it isn't built from the same fundamental particles that make up atoms, and therefore isn't built from atoms at all, in any conventional sense of that word. It has mass, and that mass produces gravity, exactly like ordinary matter. But it does not clump together, collide, or interact through anything except gravity itself. Two ordinary atoms bump into each other constantly. That resistance, that solidity, is the reason your hand doesn't pass through a table. Dark matter has no equivalent to that resistance. Two particles of dark matter can apparently pass straight through each other, and straight through you, without so much as a nudge. It occupies the same space as ordinary matter and simply ignores it. The way a ghost in an old movie walks through a wall without disturbing. Once you strip away everything dark matter is not. A form of matter that has mass. That generates gravity, and only gravity. That does not shine, reflect, absorb, collide, or clump the way ordinary particles do. In a very real sense, dark matter behaves like matter's gravitational shadow, all of the pull, none of the presence. It is the single thread connecting our familiar universe to something built out of entirely unfamiliar rules, a substance that participates in exactly one of nature's four fundamental forces and stays a ghost with respect to all the rest. And here's the detail that should really stop you. This impossible ghost substance outweighs everything we can actually see and touch by more than 5 to 1. Take a moment to picture your own body in that light. Right now, trillions of dark matter particles, if the leading models are correct, are streaming through you every single second, entering through your chest and exiting through your back without depositing so much as a flicker of energy, without triggering a single nerve, without leaving any trace that a physicist could measure. You have spent your entire life submerged in an invisible current that outweighs the visible universe 5 to 1, and you have never once felt it, because feeling it would require exactly the kind of interaction this substance seems constitutionally incapable of having. You'd think a phenomenon this strange, this invisible, would be a footnote in cosmic history, background noise, irrelevant to the bigger picture. It's the opposite. It turns out this invisible scaffolding isn't just holding galaxies together today. It built them in the first place. Without it, none of this, the stars, the planets, the very ground you're standing on, would exist at all. Rewind the clock back to the very early universe, not long after the Big Bang. At that stage, ordinary matter existed almost entirely as an extremely hot, extremely energetic gas, mostly hydrogen and helium, spread out nearly uniformly across all of space, moving far too fast and too chaotically to settle down and clump into anything. Gravity needs time and stillness to pull matter together into dense structures like stars and galaxies, and a violently hot, fast-moving gas resists exactly that kind of settling. Left entirely to itself, ordinary matter in that state would have stayed smooth and diffuse for a very long time, struggling to form the seeds of the structures we see today. Dark matter had no such problem. Because it doesn't interact with light or radiation pressure the way ordinary matter does, it was able to start clumping together under its own gravity far earlier, completely unbothered by the intense heat and radiation filling the young universe. While ordinary matter was still being buffeted and kept smooth by that early cosmic fireball, dark matter was quietly forming a vast, invisible web of gravitational wells, dense knots and filaments spread across the young cosmos, completely undetectable, but already exerting a powerful gravitational pull on everything around them. That invisible scaffolding became the blueprint for the entire visible universe. As the cosmos expanded and cooled, ordinary matter, that hot hydrogen and helium gas, began falling into the gravity wells that dark matter had already carved out, the way rainwater runs downhill into valleys that were shaped long before the rain arrived. Gas collected inside those dark matter clumps, compressed under gravity, heated up, and eventually ignited into the first generation of stars. Those stars clustered together inside the largest dark matter concentrations and became the first galaxies. Everything about the large-scale structure of the universe today, the way galaxies cluster together in enormous chains and sheets, separated by vast empty voids, forming a shape astronomers genuinely call the cosmic web, traces directly back to that early, invisible dark matter scaffolding. Run a computer simulation of the universe using only ordinary matter and ordinary gravity, without dark matter included, and you get a universe that doesn't look anything like ours. Fewer galaxies, structures that form far too late, a cosmos that doesn't match what telescopes actually show us. Add dark matter back into the simulation, and the structure snaps into place, matching real observations that terrified physicists as an unexplainable anomaly turned out to be the universe's original architect. Without that invisible gravitational skeleton forming first, gas would have stayed too smooth, too spread out, for stars to ever ignite, for galaxies to ever take shape, for planets to ever condense out of stellar debris. No dark matter means no galaxies. No galaxies means no stars like our sun. No sun means no Earth, no chemistry, no life, no you. The substance that makes zero physical contact with anything you can touch is, indirectly, the reason there's anything here to touch at all. Which brings us to the part of the story happening right now, in laboratories and observatories around the world, the actual hunt for this thing. Because knowing dark matter exists, through its gravitational fingerprints scattered across the cosmos, is a very different problem from actually catching a piece of it, and that second problem remains stubbornly, famously unsolved. One of the most striking pieces of evidence comes from something called gravitational lensing, and it turns entire galaxy clusters into enormous, accidental telescopes. According to general relativity, mass doesn't just create gravity in the everyday sense, it actually bends the fabric of space itself, and light traveling through bent space follows that curve, the same way a marble rolling across a warped sheet curves around a dip instead of going straight. When light from an extremely distant galaxy passes near a massive foreground galaxy cluster on its way to us, the immense gravity of that cluster bends the light's path, distorting, smearing, and sometimes even duplicating the image of that background galaxy into strange arcs and rings. Astronomers can measure exactly how much that light has been bent and warped, and from that measurement, calculate precisely how much mass the foreground cluster must contain to bend light by that amount. Here's the key result. When astronomers compare that calculated mass, the true gravitational mass, revealed by the bending of light, against the mass of everything visible in that cluster, the stars, the gas, the glowing material you can actually photograph, the numbers don't come close to matching. The lensing consistently reveals 5, 6, sometimes closer to 10 times more mass than the visible material can account for. Space itself is being warped by something the cameras simply cannot photograph. One of the most dramatic confirmations of this came from a system called the Bullet Cluster, two massive clusters of galaxies that collided, where the visible gas, superheated and slowed by the collision, ended up in one location, while gravitational lensing maps showed the bulk of the mass had sailed straight through, completely unaffected, exactly the way you'd expect if that mass barely interacts with anything except gravity. It remains one of the cleanest, most direct pieces of observational proof that dark matter is real, and that it is genuinely separate from ordinary matter. Lensing tells you dark matter is out there and roughly how much of it exists. It does not tell you what it actually is, down at the particle level. For that answer, scientists have to try something far more difficult, catching a single dark matter particle in the act of physically colliding with an atom of ordinary matter, here on Earth, even though every property we've discussed suggests that collision should be almost unbelievably rare. This is where the story shifts from telescopes pointed at the sky to instruments buried deep underground, and the depth isn't incidental, it's the entire point. Several of the most sensitive dark matter detectors on the planet sit at the bottom of old mines, more than a kilometer beneath solid rock, in places like the Gran Sasso Laboratory tunneled into an Italian mountain, or the Sanford Underground Research Facility inside a former gold mine in South Dakota. All that rock overhead isn't there to hide from dark matter. Dark matter would pass through a mountain as easily as it passes through empty air. The rock is there to block cosmic rays and other ordinary radiation constantly raining down from space, noise that would otherwise drown out the impossibly faint signal. Scientists laboratories sit tanks containing many tons of ultra-pure liquid xenon, chilled and shielded with extraordinary care, sitting in near-perfect silence and darkness, waiting. The logic is almost unbearably patient. If dark matter particles really are streaming through the Earth constantly, then occasionally, extremely rarely, one of them should strike the nucleus of a xenon atom head-on, causing that atom to recoil very slightly and release a tiny, specific flash of light and charge. Detect that exact signature, ruling out every other possible cause, and you've caught direct evidence of a dark matter particle interacting with ordinary matter for the very first time in human history. Teams of scientists have run these detectors continuously for years, watching, waiting, filtering out every possible false signal, and so far, nothing. Not one confirmed direct detection. Every run adds valuable information by narrowing down what dark matter cannot be, tightening the range of possible particle masses and interaction strengths, but the particle itself continues to slip through every trap set for it, exactly as its properties predicted it would. That's genuinely where things stand today. Not a settled textbook chapter, but an active, ongoing hunt, playing out in real time, in tunnels beneath mountains and in observatories aimed at colliding galaxy clusters. Multiple experiments across the globe are racing to be the first to catch a direct signal, refine the particle physics models, and finally answer the question that has been sitting, unresolved, at the center of cosmology for half a century. Nobody currently working on this problem knows for certain how it ends. It's entirely possible that within your lifetime, some detector deep underground will finally record that one impossibly rare flash of light, and dark matter will stop being a placeholder name for an unsolved mystery and become an actual, catalogued particle with a mass and a set of known properties. Or it's possible the mystery deepens further, and the true answer turns out to be even stranger than a new particle. Nobody knows which outcome is coming, and that uncertainty is precisely what makes this one of the most genuinely open frontiers left in modern physics. It's worth saying plainly, this isn't a story with a neat resolution yet, and that's exactly why it's worth paying attention to right now, rather than waiting for the textbooks to catch up. Every few years, a new detector comes online with greater sensitivity than the last. A new galaxy survey maps the cosmic web in finer detail. A new simulation tests the leading models against reality with sharper precision. Somewhere in a lab right now, a physicist is staring at a screen, watching for a flash of light in a tank of liquid xenon that may never come, or may come tomorrow. That's not a metaphor for scientific progress in general. That's a literal, ongoing experiment, happening on this exact day, aimed at answering the biggest open question in the story of the universe's composition. Step back now and look at the full shape of everything we've just walked through. Every star you have ever wished on. Every planet ever photographed by a passing spacecraft. Every galaxy captured in every deep field image ever released by a space telescope, scattered by the hundreds of billions across the observable universe. All of it, all of that light, all of that structure, all of that visible grandeur, is a rounding error. A thin, glowing film stretched across the surface of something enormously larger, older, and more fundamental that remains completely invisible to every instrument humanity has ever built. The universe you can see is not the main event. It's the exception. The overwhelming majority of everything that exists doesn't shine, doesn't burn, doesn't reflect a single photon back at your eyes or your telescopes, and yet it is the very thing holding the visible portion together, the scaffolding that gathered ordinary gas into the first stars, that shaped galaxies into the sweeping spiral patterns you've seen in 1,000 photographs, that keeps those same galaxies from tearing themselves apart to this very day. We are, in the most literal sense possible, living inside a structure built by something we cannot detect, made of something we cannot name, using rules we do not yet shift worth sitting with. We tend to think of ourselves as living inside the universe, the stars, the planets, the galaxies, the whole grand visible tapestry stretched across the night sky. In reality, we are living inside a small, unusual, brightly lit exception, a thin visible layer resting on top of a vast, silent, invisible ocean that outweighs it more than 5 to 1. Every question you've ever asked about the cosmos, every equation ever written to describe it, has so far only managed to describe about 5% of what's actually there. The rest is still out there, right now, moving through this room, waiting for someone to finally figure out what it is. Think about that the next time you look up at a clear night sky and feel like you're seeing the universe laid out in front of you. You're not. You're seeing a faint, glowing outline traced onto something much bigger and much darker, the same way a handful of streetlights might trace the shape of a city at night without showing you a single building, a single street, a single person living inside it. Every star is a landmark sitting on top of an invisible foundation. Every galaxy is a lit window in a structure whose true size we are only beginning to guess at. The universe was never mostly the part we could see. It just took us until fairly recently to realize how badly that assumption was wrong, and it may take a great deal longer to find out exactly what fills in the rest.